Topic of this lesson is the left hand and right hand rule. Now, earlier we talked about what is calculus. We came to the conclusion that calculus allowed us to do some things that algebra and geometry did not allow us to do. We first said we can find slope of a straight line using algebra, but we're interested in being able to find the slope of a curved line. And so that is what calculus is about. We're going to use what we know from algebra in finding the slope of a straight line and apply that to discover how to find the slope of a curved line. We've already done that. We also said at that time that another part what calculus does is allow us to find area of regions bounded by curved lines. Geometry allows us to find area of regions bounded by straight lines. But what we're going to do is take what we know about finding areas of regions bounded by straight lines and apply it to find a way to find the area of regions bounded by curved lines. And so that is what this lesson is all about, finding areas of regions bounded by curved lines. So this is going to serve as also as a prelude or an introduction to what we call the definite integral, which will be an upcoming soon-to-be lesson for you to hopefully watch. Example 1, how would you find the area of this region? This is not a trick question. Yes, this is a rectangle. What's the width of the rectangle? Well, it goes from 1 to 5, so the width is 5 minus 1 or 4. We say it like that rather than count because the subtraction process of finding the width is going to be a part of this lesson. So let's talk about the width as being 5 minus 1, which is 4, and the height of it is 5 minus 2, which is 3. So this is a rectangle, which is 3 by 4. Or 12 square units. Of course, you could look at it, count these bigger squares and add those up, the 12 bigger squares, or you could possibly count all of these small squares. Several ways of doing this problem without knowing anything, any formulas whatsoever. So that is a discussion there of what we just were talking about. The width of it is 3. The length of the rectangle is 4. 4 by 3 is 12. That's the area of that region. Example 2, how would you find the area of this region? Well, this is a combination of a rectangle and a triangle. So we define the area of this rectangle, and this rectangle is 4 units wide and 3 units tall, high, if you will. You find that area. And this triangle has a base that's 2 units and a height that's 2 units. And we know that the area of a triangle is 1/2 base times height. And so we'll put those two facts together to find the area of the rectangle, 4 by 3, which is 12. The area of a triangle, which is 1/2 base times height. So that's 1/2 of 4, which is 2. We would add those together. The area of the region is 14 square units. No calculus involved here in example 1, nor in example 2. Let's look at example 3. Well, this is a region bounded by, look at, well, it contains, it looks like a rectangle here, which it does. It's a rectangle that's 3 units wide and 1 unit tall or high. So we find that area. It's 3 times 1. This is a triangle whose height is 2, whose base is 1. So 1/2 base times height. And this is a semicircle, a half a circle. And the radius of this circle is 1. So we know that the area of the circle is pi r squared. Since r is 1, this is pi. But this is a semicircle, so its area is 1/2 of pi. And this is what we have. The area of the rectangle area of the triangle and the area of the semicircle, and we add these together and we get 4 plus pi over 2 is the area. No calculus involved in any of these examples. So now let's go to example 4, where we have a region that's bounded by a curve. Okay, we're bounded by the line x equals 1 on the left, x equals 9 on the right. We're bounded by the x-axis, or y equals 0 from below, but we're bounded by some function here, f of x, which we're not given what that function is. But we want to find the area of that region. Of course, I guess since we have put the grids in here, you might be able to add up all of these and these little grids here, these little squares here, and add them together. But you're going to have some error there because some of them aren't entire squares. This one, part of it hangs outside, part of it hangs inside, and so forth. So let's see if we can find a better way to find the area under this curve. Now, what we're going to do, remember we said to find the area under the curve, we're going to take what we know from geometry, which is basically the area of a rectangle, and apply it to this. Okay, that's what we're going to do here. Now, we're going to take two methods. We're getting way ahead of ourselves here. We're going to use, first of all, we're going to look at what we call the left-hand method. Now, in the left-hand method, you start looking at the region from the leftmost point, okay? The leftmost point, which is, we're going to call it A, okay? In our region here, A is 1. And the rightmost point, we're going to call B. And in our region here, B is 9, okay? So what we're going to do is we're interested in B minus A over N, okay? Where B is the rightmost point, A is the leftmost point, and AN, excuse me, is the number of rectangles, okay? This is the star of the show, B minus A over N. And every one of the subsequent slides we're going to look at, B minus A over N is going to be the engine that drives this process. So, but the thing to remember is the left-hand method starts with the leftmost point. So here we draw a rectangle, which starts at the leftmost point, one rectangle. So this rectangle, its height is 3, and its width, it looks like, is 8. So it looks like 3 times 8 is 24 is the area of that rectangle. Let's be a little more precise here. Let's look at this. N is 1. A is 1, B is 9, so B minus A over N is 9 minus 1 over 1, or 8 over 1, which is 8. Okay, one rectangle. This is the width of the rectangle, okay? F of 1, which is 3, is the height of the rectangle. So the height, which is 3, times the width, which is 8, gives us the area of that rectangle. Now, what are we looking for? We are looking for the area of the entire region. That is just the area of this region right here, far from being what we want, because this rectangle only takes into consideration this part. What about this part up here? Well, hold on, we're going to address that. That's what this is all about. But that's what you get with one rectangle. What if you divided the region into 2 rectangles? 2 rectangles. Well, it would look like this. Okay, now we start here on the left side to get our first point, and then we move to the right. Now, here's what we're going to do. The first thing you do when you do one of these problems, N is 2. we've got to find out what B minus A over N. Now, in this particular problem, B is 9. It always will be 9. And A is 1. It always will be 1. So 9 minus 1 here is going to be 8. But before we divided by 1, and that gave us an 8 for our width. Now we're dividing by 2, and this is going to give us a 4. Now what that 4 is, B minus A over N, it's the width of the rectangle, but it also is our increment. Now you say, what are you talking about increment? Well, I start at 1. Okay, and my increment is 4, so my next point is going to be 4 units over from 1, which is 5. So that's my second rectangle. So the height of my first rectangle is f of 1, which is 3. And the height of my second rectangle is f of 5, which is 8. Each of them have a width of 4. So this means that the height, we're going to add the height. Each of them are multiplied by 4, but since both of them are multiplied by 4, we're choosing to just say 3 plus 8 times 4. That's the same thing as 3 times 4 plus 8 times 4. Either way you want to look at it is fine. You're going to get the same answer, 44. That's the area under the graph of the 2 rectangles. Now, is this better than the first answer, which was 24? Yes, it is. It's a bigger answer, but we still are missing this area here and this area here. Okay, so let's proceed. Let's do 4 rectangles. 4 rectangles. N is 4. Now, let's find our B minus A over N. 9 minus 1 over 4 is 2. Okay, so that's my increment and the width of each of my rectangles. Go back to the graph. I start at 1. So the height of the first rectangle is 3, and its width is 2. I go over 2 units to 3. The height of this rectangle is 5, and its width is 2. I go over 2 more from 3 to 5. The height of its rectangle is 8, and its width is 2. And then I go 2 more over to 7, and the height of that rectangle is 13 times its width is 2. So that's what I have here. Height of the first rectangle, height of the second rectangle, height of the third rectangle, height of the fourth rectangle. All of them have a width of 2, and I do the arithmetic. And now I have the area as being 58. Still an underestimate. I'm not getting here, this, or this, but it's getting bigger. I'm closing in on the area slowly. Let's go to 8 rectangles. Now, when you have 8 rectangles, B minus A over N is going to be 9 minus 1 over 8. The width is 1, and I'm going up by 1. So let's go over here back to the thing. I start at 1. So f of 1 is 3. I go over 1 to 2. F of 2 is about 4. I go over another one, because my increment, remember, is 1, is 3. F of 3 is 5. I go over another one. F of 4 is 6. F of 5 is about 8. F of 6 looks like it's about 10. F of 7 looks like it's almost 13. And F of 8 is, we will call it 15 and a half. Okay, so there are my different heights. Each of them have a width of 1. And so when I fill it in, I put in these heights times the width, which is 1, and I get 64.5 for my answer. And that's the area now that I'm declaring the area of this. And it's still not the area, but it's getting better. You see, I have less and less area that's not under the graph. Now, I could take 16 rectangles and they would get a better answer. Of course, if I take 16 rectangles, then my width is going to be 8 over 16 or 1/2. So we're going to bring fractions into it. And of course, there's a lot more arithmetic to do, but we're not going to go any further than this. But I would like to make certain you realize one thing. In the left-hand method, we always used 1, okay, as a height. We never used 9 as a height. The left-hand method starts at 1, but it will never use the 9. Okay, this is called the left-hand method. Now you might say, is the left-hand method always an underestimate? And the answer is no. It is in this case because this is a function that's has a positive slope the whole way. In other words, strictly increasing. And that's the only reason that this is an underestimate. I don't want to say more about that other than the fact that the left-hand method is not always an underestimate, but it is for this particular situation. Now, let's revisit this graph with nothing on it right now. And what we want to use is the right-hand method. Now, with the right-hand method, you're going to start for your first rectangle is going to be over here on the right side, okay? That's the only difference. Your b minus a is the same, okay? And it's still your width and still your increment, but where the left-hand method, we start with A and move over towards, but not to B. With the right-hand method, we're going to start with B and move to the left, but not to A. Now, it's basically the only difference between the two. However, we are accustomed to reading right to left, not left to right. So what we're going to do is suggest anyway, with the left-hand method, you start at A and then you go up by whatever the increment is. With the right-hand method, you don't start at A, you start with 1 increment over from A. Okay, always. Don't start at A, you start 1 increment. I think it'll be clear when we look at what we're going to do here. So here we have 1 rectangle. Okay, what's the width of this rectangle? 8. B minus A, 9 minus 1 over 1, width. We're not going to start at 1. We're going to start 1 increment. What is that increment? Remember, our width is b minus a over n, and our increment is b minus a over n. So our increment is 8 also. So we're not going to start at 1 for our first rectangle. We're going to start 1 increment over from 1. Well, the increment is 8, so we're going to start at 8, 1 plus 8, which is 9. So there is my first rectangle. It's going to be, its width is going to be 8. 9 minus 1 is 8, and it's going to, this is its height, which is, it looks like this is going to be 19. So this is what we have here. The area of this rectangle is 19 by 8, which is 152. Now, this happens to be a great overestimate, is it not? Look, I only want this area, and I've got all of it, I've got the whole thing. So this is way too big an estimate. Hold on. Let's go to n equal 2, right-hand method. Now, b minus a over n means it's 8 over 2 or 4. That means the width of each rectangle is 4, and our increment is 4. So remember, we're not going to start at 1. We're going to start 1 increment, 4 over from 1, which is at 5 for our first rectangle. Okay, so this rectangle is 4 by, and this is its height, f of 5, which is 8. And then we're going to go 1 more increment over, which is 4. What happens if you add 4 to 5? You get 9. So the width of this rectangle is 4, and its height is this, or 19. So we'll put it all together here. Height of the first rectangle is 8. height of the second rectangle is 19. Both of them have a width of 4. So we'll add these and multiply by 4. We get 108. This is less than when we had for one rectangle. And we're hoping it will be less because we have one rectangle is a far overestimate. So we're closing in. We've come down from our previous answer of 152 to now 108. What do you think we're going to do now? N equals 4. When n equals 4, you still 9 minus 1 over 4 is 2. So our width is 2. Each rectangle has a width of 2. We're going to, and our increment is 2. So we're going to not start at 1. Remember, the right-hand method doesn't start at 1, only the left. So we're not going to start at 1. We're going to start one increment over. Well, the increment is 2. So what's 2 plus 1, 3. So there's my first rectangle. And its height is 5. Now, 2 plus 3 is 5. What's its height? 8. So that's 8 by 2. And then 2 over 5 is f of 7. And that's going to give me this, which is close to 13. I think we'll just go with that. And then we'll go 2 more over and get that, which is 2 by 19. And there we have those 4 rectangles. Okay. We're actually calling this, I did make an estimate, that's about 12 and a half there. Okay. So to be a little more accurate. So we put it all together and this is 89. Still quite an overestimate, but certainly not anything like, remember when we had that first rectangle, that was a really big. So we're closing in on the answer. Yes, we'll go to 8 rectangles now, which means that the increment and the width is 1. 9 minus 1 over 8 is 1. So remember, we don't start at 1. We start one increment over from 1, which is 2. Then one increment over from 2 is 3. One increment over from 3 is 4, 5, 6, 7, 8. So that's where our heights will be. And then we go and we measure those heights at each particular point, and we will, you can see them on the graph as we've done every time before this. So we just fill in these values. Okay, 3, 5, 6, 8, 10, 12 and a half, 15 and a half, 19. They come from the graph. Okay, they come from the graph, and we add them up and multiply by our width, which is 1, and we get 79. So that again is smaller than the previous answer. And so that is zeroing in on it from the right-hand method. Now, again, like we said before, let's say several things. The right-hand method, you do not use the 1, you use the 9. The left-hand method, you use the 1, but you don't use the 9, and so forth. Also note that this right-hand method is an overestimate, but is the right-hand method always an overestimate? No, just like the left-hand method is not always an underestimate. It's just because I have a strictly increasing function. That is, the slope is positive. Okay, so keep that in mind. So don't try to get more out of this than is possible. So that is doing it by the right-hand method. Now, we'll give you a piece of information before we go further, just for you to put in your thinking, because you may be thinking about this. The left was too small an answer. The right is too big of an answer. What if I took the average of the two answers? And let me just say to you, you're on to something. But that's part of another lesson. Okay, that's part of another lesson, not for today. So let's see if we can come up with a menu. Before we had a graph, what if you're just given a function, y equals x squared, and we're told that x goes from 1 to 17, okay? And we're told that we're find the answer left and right for n equal 4. So we're going to do the left-hand method and the right-hand method for this when from 1 to 17, where this is our function. So let's look at this. Let's do, first of all, before we begin, we need to find our star. The star is the same for the left and right. So we'll take 17 minus 1, which is 16, divided by 4. That's 4. So that's my star. That's the width of each rectangle, and that's my increment. So left-hand method requires that I start at 1 and stop 1 short of the right endpoint. The right-hand method means I start 1 increment to the stop at the right end, to the left end point, one increment beyond the starting point, which is the left end point, and we stop at the right end point. Okay, I think it'll be clear when we look at this. So let's do the left hand. So we're going to start at 1. Okay, we're going to start at 1, and that's my first rectangle, f of 1 times 4, and then go over an increment, so that'll put us at 5. 1 over from 4 is 5, and then 1 over from 5 is 9, and 1 over from 9 is 13, and we don't go to the right hand, which would be 17. We don't. This is the left hand. 1, 5, 9, 13. Now, what is well, a factor of 4 here? You can, or you don't have to, but we've chosen to factor out this. Now, where am I getting these numbers down here? Well, remember, my function is x squared. So f of 1 is 1 squared. F of 5 is 5 squared. F of 9 is 9 squared. And f of 13 is 13 squared. You add these together, multiply by 4, and that's your answer. In other words, that by the left-hand method with 4 rectangles is an estimate of the area under the graph, y equals x squared. I think you can envision what y equals x squared. It's one that you've known for a long time, hopefully. It's just a simple parabola. Okay, now let's address it from the right-hand point of view. So we're going to start not at 1, but 4 over from 1, which is 5, then 9. 4 plus 5 plus 4 is 9, and then 13, and then we use 17. Remember, the right-hand method uses the 17, but not the 1, and the left-hand method uses the 1, but not the 17. So now we put these values in. Again, it's 5 squared, 9 squared, 13 squared, and now we have 17 squared, and that's the answer. This is the area under the graph by the right-hand method. Now, this is a great problem for you to look at because it really tells you, do you know what you're doing? In other words, there's a rhythm to this thing. First thing you do when you get to the problem, you take and find your b minus a over n. That's your width, and that's your increment. And know that the left hand means you start at 1 and go up by 4s, 1, 5, 9, 13, and the width of each of the rectangles is 4. The right-hand method, you start 1 over from 1 increment over from 1, which would be 5, and then we go up by 4s, 5, 9, 13, 17. We get these values by simply substituting into the function that was given to us, do the arithmetic, and each of them have a width of 4, and we get that answer. You need to look at this problem more than any of the other. The others were to explain to you what's going on, but this is a concrete problem which basically has a menu and probably is very doable for you, hopefully. Now, we want to finish with one last example. F of x equals e to the x squared, and we want to do it by the left-hand and right-hand method for 2 reasons. One is it'll give you another chance to see that this thing is automatic. And the other thing is this is a function that you cannot do pretty much any other way. In other words, we're going to show you later in the course a shorter method to get a more accurate answer of the area under the curve. Not today, not in this lesson. But this is a problem that we cannot do a shortcut method on. So the only way we're going to be able to do this is this left-hand, right-hand approach. Now what we're doing is, here's our function, e to the x squared from 0 to 2. And we want to find, we're told that n is going to be 4. left-hand and right-hand. But let's see what you do. First of all, here's your star of the problem. B minus A, 2. Now A is 0, B is 2, so it's 2 minus 0, which is 2 over n. So that's 2 over 4, or 1/2, 0.5. That's your width, that's your increment. So left hand, start at 0 and go up by half. So it's f of 0, go up by half, f of a half, go up by half, f of 1, go up by half, f of 1.5. Now, you're going to have to use your calculator on this to find these values. In other words, this is what you get if you let x be 0 here, okay? And so, of course, e to the 0 is 1. That's pretty trivial, but then you're going to have to use your, these are gotten by putting the value 0.5 in for x, squaring it in e to that power. We get this number and so forth. And so we add these up, multiply by half, and this is an approximation of the left-hand answer. Now, the right-hand answer doesn't start at 1. It starts a unit over, an increment over, and my increment's a half, so it starts at a half, then goes up by a half to 1, goes up by a half to 1.5, and goes up by a half to 2, which we expect. Left-hand answer starts at 0, 1 shy of 2, and the right-hand answer, 1 increment over from 0 and ends at 2. Again, you put these into your calculator to get these numbers, add them up, multiply by half, and this is an estimate by the right-hand method. Now, this is not a very accurate answer here, because this function rises very, very quickly, and it's only a short window here. So this is not anywhere near close to what the exact answer is. But that's not the purpose of this. We really want to show you one that you need to know this left-hand, right-hand method for. That's the way to do it. Or a technique that's similar to this. There are other techniques, but they all play off of the same template, okay, of the b minus a over n. So, and also you see that the left hand you start at 0 and end 1 increment. Before you get to 2, the right hand you start 1 increment over and you end at 2. So there's a lot to be said for this particular problem. Now, this basically concludes this lesson. We've going to launch from this lesson, as we said, we're going to something called the definite integral in the very near future. And so this lesson not only gives us a tool for finding area of the graph by hand, but it also will give us a way to launch into another topic that will be probably even more helpful to us than you realize at this time. So this concludes this lesson.